Alrighty, good morning everyone. This is 4.6 note-taking with vocabulary. I know we started off on a different page, but towards the bottom it says 124 of the big ideas notes, note-taking with vocabulary. Give me one moment here. There we go. Just locking up on the focus. So we're going to start with note-taking with vocabulary. We'll go to the first couple pages maybe later on in order to use our calculators and maybe our iPads in order to see just the relationships between these. But we're going to start with similarity transformations. And similarity transformation is a dilation, a composition of dilations, or a composition of rigid motions and dilations. So another way to kind of read this textbook definition is really you have a dilation and another figure or another transformation. And we talked about transformations. Those can either be translations, reflections, or rotations. So it can be any of those three. So this is where we're taking a figure or a line, some sort of object or figure that we have, and we're either going to translate it, reflect it, rotate it, and then dilate it, or we're going to dilate it and then translate it, reflect it, or rotate it in some way, form, or fashion. So that's pretty much what this is. It's like a combination of things, of everything we've learned, and it's going to happen to this figure twice. So now we're going to talk about the similar figures. This is where we talk about the actual figure itself. So this is where we have two geometric figures. So this is where you have like your two geometric figures, just like your image and then, or your pre-image and then your image. And so it's only two geometric figures if and only if, and we talked about if and only if, that's a biconditional statement. So two geometric figures if and only if there is a similar transformation that maps one of the figures onto the other. We ran out of space. So figures. So this is just your, we were saying that you have your pre-image and your new image after you've done it the very last time. Okay, so those are your definitions that we'll be going, or that we'll be talking about today. So let's start off with practice. It's the best way I like to take notes, is always practicing. What does similarity transformations and similar figures look like? When you turn over to the next page where it says extra practice, I have example 1. And so I have to where we have a figure with 4 vertices, and I'm going to translate it, x minus 5 or y minus 3, or in vector form, that would be -5, -3, and then I'm going to dilate it around the center at k equals 3. And k equals 3 is pretty much saying scale factor of 3. So it's pretty much you're scaling it bigger at three times its way. So I like to rewrite things. So I'm going to go ahead and give you the pre-image. So A, B, C, and D. And we have A is 3, 6. B is 2, 5. C is 4, 3. And D is 5, 5. So first thing we're going to do is we're going to translate it. So let's just graph our original figure first. Let's graph our pre-image. So our first one is at 3, 6. A is at 3, 6. B is at 2, 5. And then C is at 4, 3. And D is at 5, 5. And that's D. Okay, so I have A, B, C, and D, our original figure. So now I'm going to take this figure and I'm going to slide it over -5 and y -3. So I'm going to take my new A prime, and when I do that, this is the same as saying taking my 3 minus my 5. I end up with -2, and then I will take my y coordinate 6 minus 3. So now 6 minus 3, which is 2. Okay, so we're going to do that for all of our coordinate points for A prime to get our first translated image. Oh, I'm sorry, and then 6 minus 3 is 3. There, got that figured out. So B prime is -3, 2. And when I plug in my points, C prime is now -1, 0. And D prime is 0, 2. So now we've translated our image with our primes. So let's graph this new figure. So I have D prime is at 0, 2, and then C prime is at -1, 0. A prime is at -2, 3, and B prime is at -3, 2. So this is our figure that is translated. Okay, so we've slid down some based on our translations, our vector form, -5, -3. So now we're going to dilate this entire figure by a scale factor where k equals 3. And so the shortcut way, when we did notes last time, you're going to take your first coordinate point and multiply by your scale point, and then take your y coordinate point and multiply it by your scale factor, and then you'll have your new coordinate point. So for A double prime, just to show you the steps, I now have 3 times my scale factor 3, so that's for my x coordinate, and then I have 6 times my scale factor 3, and I end up with my new coordinate point, and I end up with